Okay, inverse functions can be done one of two ways. So what we're doing is to start with, and this is revision, but the inverse function is the opposite. So in this one, I'll start with y equals 3x minus 4, and I'll plus the 4 across and divide it by 3. So I've changed the subject to x and then written, don't forget the inverse is the minus 1 at the top, x plus 4 on 3. Done the same here. I've changed x to be the subject, so x is y squared. Therefore, the inverse function is of root x is x squared. Y equals log x to the base 3. I've had to change it to be an indice, and that's made x the subject, and I've put in my inverse function. So once I have the other as the subject, then I can just change the x value in the notation. You might find it easier if you swap them to start with and then get the y on its own. Okay, I've done that in this first one, so I've swapped the y and the x. So x is root y minus 4. I've squared it, I've added 4, so I've got y equals x squared plus 4. That's my inverse function. Swapped it here again. X is 3y to the 4 minus 5, added 5, divided by 3, took the fourth root, and that gives me my inverse function. Okay, mutually exclusive inverse function is where one undoes the other. So show that if f of x is 3x minus 5 and its inverse function are mutually inverse functions. So if the function is 3x minus 5, I found the inverse function to be y plus 5 on 3, and I've substituted into the formula. This never comes up, and if they wanted you to do it, they wouldn't use the word mutually inverse functions. They would say, show that that equals that, and then show that it equals x. So I'm not so much worried about this. That's a higher developed proof, and you've got to understand that if I've got the everywhere that the x is in the inverse, if I sub it in, it should equal x, and if in the function, if I sub in the inverse, then it should work.